this on. All right. So as the video suggested yesterday, the t-test was developed by an individual who went by the alias name of Student, but his real name was William Gossett. And what he really wanted to do is come up with an objective way to determine whether or not two sample means or a sample mean compared to a population mean are really significantly different. I should say that at the bottom of the slide here, it says he was one of the students of Carl Pearson. And as we will see, Pearson created the correlation coefficient, which we'll get to in a little while. But basically, when we're looking at analyzing data, we kind of have a decision-making tree, okay? Is one, the first question that we ask is, what sort of data did you obtain from your investigation? So, so if it's a measurement, we took some type of a measurement, then we're going to go to one of these three areas to investigate. If, however, we look at categorical frequency data, we're going to use this non-parametric method of chi-square. Okay. So we're gonna leave this out for now. So let's not think about categorical data. Okay. We took a measurements. If we want to look at the association between different measurements made from the same sample, we're going to do what's called a Spearman's rank correlation, which we will get to in about another week. If we're looking at the association between measurements, we are going to use a Pearson correlation of two variables. So when we're looking at associations between samples, we're going to use a Pearson. When we're looking at association between variables, we're going to use the Spearman for the sample, Pearson for this one. So in this case, this would be like if we wanted to know if the grades for stats math 225 during the summer are associated with math 225 grades in the fall. We're looking at the sample, not necessarily the measure. When we're looking at the association between, let's say, sleep and performance, those are two separate variables that we think are associated together. We're going to use this correlational method. But what we're doing right now is we're looking at differences between measurements from different samples, okay? And this is where we're looking at differences. So we're going to do a t-test when there's just two. If there's two or more, then we're going to use an ANOVA, which we will get to next week, okay? So what can a t-test tell us very specifically? And that is if there is what we call that statistically significant difference between two means. And remember, statistical difference is a p-value or alpha value, you can write it either way, of less than or equal to 0.05. Okay. Now, the t-test does require something, and that's that our data be normally distributed. The other criteria that we have to look at is whether or not the variance between our two samples are equal or not, which we will get to when we run some tests on Monday, and I'll show you what that's all about. There are three basic types of t-tests. The first one is called an independent samples t-test, aka two-sample t-test. This is where a measure has been taken from two independent samples, the same measure, and we want to know if they're statistically significantly different or not. Okay, so this would be an example of measuring, let's say, measuring everybody's level of loneliness. I'll go with that because I was writing about it earlier. And so what we would want to know is, you know, let's compare genders in the class. So we wanted to see if males or females were more or less lonely, or if they're the same. We have two independent samples, males and females, with the same measure. That's an independent sample t-test, okay? A one sample t-test is when we know what the population mean is, and we know what the population standard deviation is, but we want to compare it to some sample mean, okay? So what we're comparing is a population mean with a sample mean, and what we want to know is there equal, well, actually greater than, lesser than, or just not equal, okay? And an example of this would be, let's say I have the performance scores for all stats 225 students, and I wanted to know if this class is performing higher or lower than what the population mean for stats, math stats students are. In this case, you would use a one sample t-test to determine that value, okay? A paired samples t-test is when you're measuring the same individuals, the same sample at different times. So this is the example that was used quite a few in the video, is when you measure before and then you put in some type of treatment and then you measure after. And so you would do a paired samples t-test to compare the pre-score with the post-score, okay? And these are the three types of t-tests that you can perform to compare groups, two groups together, okay? Let's go over the equation to kind of understand what's going on here. So this is the first mean. So this is kind of the independence t-test where we're comparing two sample means together. What we're going to do is take a sample mean of one and subtract it from the sample mean of the other. This gives us the difference between means, okay? But then down here, what we're going to do is we're going to take the standard deviation of the first sample, divide it by, square it and divide it by the sample size of the first sample, and add that to the sample, the standard deviation of the second group. So all of this is associated with this, while all of this is associated for this, okay? We're going to add these together, and then because we squared the sample standard deviation, we need to take the square root to make the number come back to what it should be, the t that comes up with the t statistic, okay? Now, we're going to take the combination of our standard deviations and we're going to divide it into to our differences in means. Now, if we read this, this is what this is saying. There's a, the difference between, now follow with me, the difference between the sample means controlled for the variance. So when we divide something into something, what we're doing is we're controlling for that variance. Okay, equals a t statistic. Okay, and what this is going to tell us is it's going to tell us if those means are different based upon controlling for the variance within the two samples. That's what this equation is basically saying. So to say it again, what the t-test is looking for is differences between the means when we control for the variation or the standard deviations. That's what a t-test really means, okay? And this is kind of an example. So if we have pH in a soil, for example, and we have group 1 and group 2, and one is 5.5 and the other is 7, and 50 seeds for each pot, and the number of germinations in each pot was recorded. Okay, so we're going to look at growth rate dependent on pH level. Okay, so again, as we did on Tuesday, we start with the null hypothesis. The null hypothesis is that there's no statistically significant differences between germination success of seeds in two soils of different pH. And then, of course, our alternative hypothesis is there will be significant differences in the germination, okay? So again, we set the p-value at 0.05, and if our t-value exceeds the critical value for that probability, then we can reject the null hypotheses, okay? So let's take a look at how this is gonna go. So here we have construction of the following table, and we see and we can see that they set up all the values, pot 1 through 8, and then you have the pH and the pH, and then you have the differences, and then you square those differences, and that's how you get this. So this is where our means are going to come from. Okay, so group 1, we're going to figure out their standard deviations. And then we're going to take the means, subtract them from each other, and we get this. We divide that by the square root of the standard deviations divided by n. And we come up with a t statistic of 2.9, okay? Now, what does this t statistic represent? This is an example of the table that was talked about earlier, but this one is set up on degrees of freedom, okay? Now, degrees of freedom for a t-test is the sample size in 1, so this would have been pH of 5 point whatever, sample plus a sample size of the second sample, which was a 7 point something, and then you subtract 2. And you come up with 14 degrees of freedom, okay? Now remember, when we talked about degrees of freedom, all we're saying is we're providing room for variability within our sample. So we're going to, in order to do that, we're going to subtract 2 because we're going to give a degree of freedom to this sample, and we're going to give a degree of freedom to this sample, okay? Hence, we end up with a degree of freedom of 14. And then we look at this and we go on this table, it uses degrees of freedom, and we see that 14, the critical p-value for degrees of freedom of 14 is 2.15. Our statistic is 2.99. Okay. So what we could say at this point is that hold on. What we can say at this point is that X1 means are not the same as X2. And does it give? Oh. And so we know that there is a difference based on pH level. So let me show you how you would write this out, because it's important to note the notation, because I'll expect you all to be able to write these out, okay? So the way this would be written out would be a small t, and then in the parentheses, you would put the degrees of freedom, and then you would put equals 2.99 p less than 0.05. And that's how you would write out your t statistic in an answer is right here. Okay, so again, where we get these numbers, we get t with degrees of freedom of 14, which sets a critical value of 2.15. And we know that our t value is greater than 2.15. So we know that the p value is less than 0.05 because it's greater than the critical value. Okay. And Diana, I saw that you had your hand up.
So real quick, so I'm not missing any steps.
All right.
So you get your degrees of value of freedom by adding the 5.5 and the 7.0, right?
No, but you get the degrees of freedom by adding the two sample sizes together.
Oh, the sample sizes.
Yeah. So in this one, there was 8 in each sample. So together it would be 16. And then you subtract the 2, which gives you the 14.
Thank you.
You're welcome. Here, let me write that out because I think it's easier to illustrate. So 8 plus 8 minus 2 equals 14. And I do want to explain why this is important is because when we get into ANOVAs, when we're comparing more than 2 groups, dependent upon your group size will determine your how many degrees of freedom. So if we had another sample here, let's say we had another sample of 8, so we have 3 groups, we would subtract 3 because we would need to give a degree of freedom to each sample. But that was a very good question, and thank you for allowing me to clarify.
That was going to be my next question. Why are we subtracting by 2? And you just explained it. Thank you.
Good. All right. Excellent. Okay. Now, again, I just want you to be aware of these things so that you kind of understand it from a education perspective. But again, when we get into this, the software will provide you with all of these numbers that you need. It's just, I really want you all to have a good conceptual understanding of what we're doing, which is basically we're comparing 2 means while controlling for the variation between those means so that we know that it's not due to sampling error or error due to variation that created the mean differences, okay? And so that's really what we're doing with the t-test itself, all right? So that is t-test. And I'm trying to think. And as I mentioned, I really would like to spend the rest of the time for this class allowing everybody to get caught up on their work. And so I think I want to honor that. But what I would like you to do in the meantime is I want you to kind of look at this lecture, look at the video yesterday, and just jot down some questions that we could start with in the chat on Monday. Because on Monday, we'll generate some examples and we'll take some literal looks at some different type of examples. We'll run some hypothesis tests using the t-test procedure. That way you also have the analytical part of it. So what we're really trying to do at this point is get a conceptual understanding of the tests that we'll be running, and then the ability to interpret those tests will be the main focus of this t-test and all the other tests moving forward. So that's kind of where we're headed. But is everybody okay? Let me allow you some time to go catch up on your work and everything. And then and then kind of think about the t-tests and questions you can ask on Monday. Does that work for everyone?
Yeah,
All right. All right, I have plenty of yeses. All right, so let's do that. Please use this time to get caught up if you need to. If you're already caught up, kind of look at the t-test stuff we've been talking about and get any questions that you may have, and we'll go through it. And we will look at some different types of tables on Monday as well. So, okay. All right, everyone have a wonderful weekend. I look forward to seeing you all on Monday.
Have a good day.